Very simple. Hydrogen ions versus bicarbonate ions. Okay. You have to like break this out. And your kidneys have a choice. Are they going to secrete or reabsorb? Let's think about the difference. Secretion. So if you don't know where the directions of these processes, you're screwed. Secretion means something's getting added right into the urine, right into the tube, okay? And then you're going to eliminate it. Reabsorption means it's going back into the blood, right? So assume now that your situation is that you are acidic. You have acidosis. So if I told you you have acidosis, that means your blood pH is less than 7.35. So if you have acidosis, are your kidneys, don't yell it out, try to fill it out for yourself, will they increase or decrease the secretion of hydrogen and then bicarb? Will they increase or decrease the reabsorption of either hydrogen and bicarb to help remedy the situation? But take a second and see if you could fill this out. So your pH is less than 7.35 in your blood. How are your kidneys going to change the secretion and reabsorption of hydrogen and bicarbonate to fix the problem? It's an up or down thing. It's a 50-50 crapshoot, okay? Yeah, Jocelyn.
They're going to secrete more bicarbonate to absorb the...
That's right. There's going to be an increase in bicarbonate secretion. No, that was wrong. I went with you, and I shouldn't have gone with you. Okay.
I do.
Where?
So it's
Where?
arrow up top.
This thing?
Yeah.
Here? What works with that?
I don't know.
No.
So,
That's okay. We'll start again. We're fine. You know what, Jocelyn? I gave in to you. This is why you should. Whoever asked me something before, don't believe anything I said. It was you, Chris. You guys were asking. I'm like, I don't know Jack anymore.
So it secretes more
Well, now we know it's not.
H plus.
Okay, so you have a pH less than 7.35. Bless you, wherever you are. So you're acidic. So this is how I think of it, okay? Because I'm simpleton, as we just viewed from that one, okay? I'm a simpleton. So you're acidic. You have too much hydrogen. You need to get rid of your hydrogen. So what are you going to do? You're going to secrete it into the urine to eliminate it. If you secrete your bicarbonate, what?
I get it now.
Yeah, I know.
Understand? Yeah.
Yeah, I just gave in to you. I know you understand. You're smarter than me. You said something and I went with it. I didn't even think. Very bad. So back to this though. You have a low pH, you have too much hydrogen, so you're going to increase the secretion of the hydrogen into your urine to eliminate it. The last thing you're going to want to do is reabsorb it back into the blood, because that would make your pH even lower. Right? And then once you figure one out, the other one's opposite. But just for the sake of explaining it, you have a low pH, you have lots of hydrogen. If you secrete your bicarbonate into the urine, you lose that buffering capacity. You don't want to secrete it into the urine. You want to reabsorb that bicarbonate back into the blood so that you can raise your pH.
Oh, okay. I got it backwards. I thought that it was secreting the bicarbonate into the blood.
See? That's why we have to know which direction these things are going. Secretion into the urine, into the tube to eliminate it, and then reabsorption back into the blood.
Okay.
So you can ask a lot of questions on this. So a lot of people just write this down. So if your pH is greater than 7.45, then you have alkalosis. So what's going to happen now is obviously the exact opposite, but you need to have more hydrogen in your blood, so let's reabsorb it. Let's not pee it out. You have too much bicarbonate, so don't reabsorb it, pee it out. Okay. So memorize the table, get you the points. Understand it, it's yours forever. It's true. It's like this. Joe Blow, this is how I know. Joe Blow has type LM positive blood. What are the antigens on the surface? What antibodies does he make, you know? Once you understand it, you know on the surface are L's, M's, and RH. and you know he does not make anti-L, anti-M, or anti-RH. Once you get it, you can change it all around. Once you understand it, it's yours. So anyway, this is summation of lots of your textbook right here. And this is the take-home of it all. Okay? So anyway, that's what I want to tell you. Now, let me just finish this up. This is the very last part. You've heard of somebody having respiratory alkalosis or acidosis versus metabolic acidosis or alkalosis. You need to understand the difference between the two. Okay? So in respiratory acidosis or alkalosis, the problem is with the respiratory system. So the respiratory system cannot help you fix it. Your respiratory system is broken for whatever reason it may be, all right? So there's no possible way that, when the question says, in response to respiratory acidosis, which of the following will occur to help the patient? You can never pick an answer that says respiratory rate goes up or down. That cannot be a choice because their problem is with their respiratory system. So instead, what will help them would be the chemical buffer systems and the urinary system. Does that make sense? So you're like, in this class, which is not real life, I'm saying the person has got trouble with their inspiratory center in their brain, you know what I mean? Like that, you can't fix that quickly. So you won't pick an answer. So if someone has respiratory acidosis, that means that they have a low respiratory rate and they have high CO2. That's their situation. So what will happen? The chemical buffer systems will, and since they have high CO2, that means they have high hydrogen, and hence they have a low pH. That's like a given, right? So what's going to happen is the chemical buffer systems, the base part of those chemical buffer systems will work to try to remove that free hydrogen and raise the pH. In response to respiratory acidosis, will the kidneys increase or decrease secretion of hydrogen? In response to respiratory acidosis, will the kidneys increase or decrease secretion of hydrogen? Say it, please.
Increase.
Increase. So they're going to eliminate the hydrogen from the body. That's why your pH of your urine is 4 to 8.
I'm confused, but with respiratory acidosis, your body would increase your respiratory rate to fix it.
No, you cannot. You can't fix. The respiratory system is broken. That's the cause of the problem. So the respiratory system is not fixing the problem. The other parts of your body are fixing the problem. Now, don't tell me what you see clinically right now.
Okay.
That's why I said you have an injury in your inspiratory center. The respiratory system can't fix. Okay, someone is strangling me.
So you're saying not putting somebody on a ventilator, somebody that.
Right, no ventilator. That's me. Right now, someone's trying to strangle me. I am not breathing, right? I cannot breathe because I'm being strangled. So hence I have low respiratory rate and more CO2. Me breathing more is not an option. But what can fix my pH? Chemical buffers, the base part, and increasing hydrogen secretion into the urine. Will that be enough? No. Will I still die? Yes. But those things will happen.
So like if you had a problem where your lungs weren't
filling up with the air properly.
Yeah,
you had
so
big
like,
wads of mucus and
like
you couldn't get
cystic
good gas
fibrosis
exchange.
Or pneumonia,
Right,
or
exactly.
emphysema, something
Right.
like that.
That
Your body would be taking care of that.
Other ways,
longer term.
other ways, okay? So you cannot pick an answer that the respiratory system is trying to fix the problem when the sickness is with the respiratory system. Does that make sense?
I understand what you're saying.
You do?
I'm glad you said that too.
Because you're reading too much into it. Yeah, you're reading too much in. I'm a simpleton, remember. You know what I mean? Like I don't have the clinical background, so I'm just like, this is just like a book definition, okay? So obviously, if I hyperventilate too much, I have high respiratory rate from hyperventilating, and I keep doing it. I don't want to stop, right? Hyperventilate, so then I will have less CO2. So that's going to cause me to have less free hydrogen, and it's going to cause my pH to go up. Now, I'm still doing so my respiratory system cannot fix the problem because I am consciously hyperventilating, but the acid part of the chemical buffers will add free hydrogen to the extracellular fluid to help raise the pH, right? Or lower the pH rather, excuse me. And then the kidneys will increase reabsorption of free hydrogen. Do you guys get it? But the respiratory system can't fix it because that's the problem. Okay, so that's respiratory acidosis or alkalosis. The problem is with the respiratory system. That's different than metabolic alkalosis or acidosis. Here, the respiratory system is functioning, so it can help fix the problem. The problem of being acidic or alkaline comes from some other thing, like in metabolic acidosis, I would not know about that, but if you had too much alcohol, or if you had chronic diarrhea, because with diarrhea you lose bicarbonate from the large intestine. So now you have metabolic acidosis. You have lots of hydrogen, and you have a low pH. Now the respiratory system can fix it. So what will happen to respiratory rate to fix this problem? Will it go up or down? It will go up. If respiratory rate goes up, we'll have less CO2, less free hydrogen, and the pH goes up. So you see the difference here. The respiratory system can come into play. In the situation of metabolic acidosis, the same answers apply for the chemical buffer systems and the urinary system. In metabolic acidosis, the base part of the chemical buffers will be working to remove the excess hydrogen. The kidneys will increase hydrogen secretion into the urine. The different answer here is that respiratory rate can change to help the problem. In metabolic alkalosis, like if you have severe vomiting, then you lose lots of hydrochloric acid. So in metabolic alkalosis, when you have less free hydrogen, because you vomit so much, and your pH goes up, then the respiratory system can come into play, respiratory rate can decrease, that helps you to retain CO2, to raise free hydrogen, and lower your pH. Okay, so I hope I showed you the distinction. You need to go over the distinction, and when you get a question, it should be very clear. Joe Blow has respiratory alkalosis. Which of the following will help compensate this situation? Do not pick a respiratory answer. Pick a chemical buffer or a urinary thing, secretion reabsorption. Or Jane Blow has metabolic alkalosis. Which will help her? Now all three are available for you. And I've only just stressed to you, since you've known me, how important the central nervous system is to changes in pH and why you have to keep that constant. So this is just a review of the various electrolytes. That's about it. And here, this is a good metabolic and respiratory acidosis, alkalosis, and what could happen to you, God forbid, because you should, have these things. So if you know anything about this chapter or anything about acid-base, I just skimmed on the top of it. But believe me, there's a reason. I've been doing it long enough, and if you believe me. You're all going into different fields. You're all going to do something different. If you understand that if you have acidosis, that your kidneys will add more hydrogen to your urine, and you remember that, in 5 years, I did a good job with you. Because you're never going to remember the chemistry behind it unless you're a chemist person. If I tried to teach you all those chemical things, your eyes will glaze over. You won't remember jack shit after the test. I'm hoping that in the end, you'll understand how these three systems in our body, three ways in our body, try to keep the pH constant. That's my take home. That part. Right, so